Hi, good evening. All of you will be busy preparing for your examinations, I know that. But then here since Moments is the first time that you're going to appear for AS level, I would want to give you an in-depth understanding or a bit of brief before you appear for your exams, all right? Now, quickly we'll go through how to approach a question on moment, all right? If as I've told you in Unit 3, what all the key points that you have to keep it in mind. Similarly, for moments, if you keep these checkpoints in your mind, I'm pretty sure you will be able to handle the question a bit more easier and you would avoid mistakes, all right? Okay, first thing, in any given situation or in an application, first try to identify the center of gravity of the system as a whole, all right? So what does the center of gravity represent? The weight of the system will be acting through the center of gravity. Not only for these type of questions, any moment questions, whether it's in equilibrium or will it topple over, etc. I'll discuss that in a bit. So first key point is identify the center of gravity because the weight will be acting through it. So majority of the question, they may not mention the weight of the system. You will have to figure it out whether the pivot is at the center or not. Okay, so the first checkpoint is center of gravity. Then second, the pivot. So what do I mean by pivot here? Now, if it's a seesaw, we all know where the pivot or the fulcrum is placed. Exactly, that's going to be the fixed point in that particular situation. But then there might be situations where you're not sure where exactly for example, like you're using a lever to, like a fork to open a lid, okay, of a can. So we have got the can here. You use the fork, right, to lift it. So where is the pivot here? Now you're applying a force down here, right? You'll be applying a force here. So there is movement on this part, the handle of the fork, and the lid will be lifted off from here. So where is the fixed point where the fork rests on the edge of the can? Right? This I've given you one example. Similarly, apply it to the given situation. Which part of the system will be at rest, which will not be moving in the whole system? That will be the pivot point. Okay. So second main identification point would be pivot. So identify center of gravity, then pivot. Third, okay, I'll come to that later. Forces through the pivot point. That's also important because when you have that something rest, we all know there is a contact force or reaction force. So there are equal forces acting in the opposite directions. So you must remember that as well. Now coming to perpendicular, this is very important because in IGCSE or lower grades, most of the forces will be acting perpendicular to the pivot. But in AS level, expect that the angles may not be perpendicular, so be prepared for that. So if it is at an angle other than 90 degrees, then you might be in a position to find the component of the force, right? We'll have to apply the component of force, or maybe the distance, you can take it in a different angle that you will understand it while we are solving questions. So make sure the force and the distance calculation, they are at right angles to each other from the pivot. Okay, so these 4 points, if you keep that as a checklist while solving or after solving, if you're rechecking, these are all ticked off, I'm pretty sure you will not go wrong. Okay, now we'll see a very simple question here and I'll tell you how to identify this. Now here I've just shown that there are two forces, F1 and F2. I've not given values. Now, are these the only forces acting on the system? No, there are more forces which are not shown on the diagram, which are, now you will have two reaction forces here because this is resting, so you will have one force acting up, two normal contact forces acting up, and you will have the weight of the torus. See, this is longer, so the weight must be closer to, if you assume this to be a regular beam, it's going to be pretty close to this pivot. Okay, if I label this as P1 and P2, the center of gravity will be much closer to P2. All right, so you will have the weight acting downwards. Here, so now I have identified the forces. Now So the center of gravity I've identified the forces acting through the pivot point and through the center of gravity, the weight, right? Then what do I do? See, I told you to identify the pivot, but then in this case, see, there are two pivots, P1 and P2. So which one will you take it as, the fixed pivot and proceed? In fact, you can use any of these. If you apply principle of moments correctly by using either one of the pivots, you will arrive at the correct answer. All right. Now, some questions they may ask you, calculate the moments about a fixed point like P1. They could ask. In that case, you must use P1 as your pivot. All right. If they have not mentioned, if there are more than one pivots, then you have a choice to choose any one of the fixed points. Got it? Okay. Now, say I'm going to use, or I'm going to calculate the moments acting at the point or through the point P1. Then how do I solve? Now, forces through pivot point. Now, will I consider this force into calculation if I am taking P1? This is very important, right? I repeat, do I have to consider moment acting due to this reaction force at P1? I don't need to. Why? Because what is the perpendicular distance from this P1 for this force? 0, right? There is 0 distance from this particular pivot P1. So this will not have any turning effect at this point P1. Okay, so this force can be ignored for calculations if you are taking moments about the point P1. This is very important. Now, as I said, I have a choice of using P2 as well as my point of reference or the moment calculation. In that case, I will omit this, but I will include this because this force is at a particular distance from P2. Getting it? So I'll write about P1. What would be the correct equation that you will apply? Now look at the clockwise moment. So from here, from this point, these two are acting in the clockwise direction. This one is acting anti-clockwise direction. This force is also acting anti-clockwise direction, right? So about P1, you will have from P1 multiplied by this W multiplied by this distance. So W multiplied by, say, D1, all right, plus F2 multiplied by D2. What would that D2 be? The D2 will be the distance from P1 till F2, right? Because this is the pivot, so this distance will be your D2. So I've included all the clockwise moments. So what will that equal to? Counterclockwise, I will not include this because this is cancelled, as I said. Now I will take this, if I take the reaction forces R2, say this is R1, then this will be equal to R2 multiplied by the distance from this pivot. Say we take that as D3. Plus, now this force, which is F1 multiplied by the smaller distance, say it is D4. Once you get the equation correctly, then whatever is missing, whether it's the distance or force, you'll be able to apply it. All right. So keep that point in mind. About a particular point, if there are forces acting at that point, ignore that, and the rest you will have to combine by applying principle of moments. Now about P2, how would the equation be? From here, if you look at it, you have only this force acting clockwise. Sorry, this force clockwise, and this reaction force is also clockwise. Correct? So it will be F2 multiplied by this distance plus R1 multiplied by this distance will be equal to W into this distance and F1 into the whole distance. I hope that's clear. This I gave it intentionally where you will be able to identify if there are more than one pivot. That particular pivot, from there you take all those forces that are acting in one direction clockwise, equate that, all those moments acting clockwise, equate that to all those acting anti-clockwise, and then combine the quantities. I hope you will get that correct. All right. Now